We're going to understand star classification and types of stars. If you haven't heard about star classification, well, good, you have landed in the right video. The classification of stars based on their spectral characteristic relation between wavelengths and some other variables. And classification is a scheme for assigning stars to types according to their temperature and, uh, and their luminosity, and estimated from their spectra. For most of our active life, a star shines due to thermonuclear fusion of hydrogen into helium like that in its core, helium in its core, and releasing energy that traverses the star's interior and into outer space. It explodes into outer space, and the star's life begins with the gravitational collapse of a gaseous nebula. A gas cloud means a gas cloud, and materials composed primarily of hydrogen along with helium, trace amounts of heavier elements like silicon, iron, helium, and hydrogen. And these heaviers, when the stellar core is sufficiently dense, hydrogen becomes steadily hydronuclear fusion through a nuclear fusion and releasing energy in the process according to the latest data. That process is called thermonucleic fusion. And the observer contains 1 times 10 to the power of 24 stars. The nearest one to our planet is sun, and scientists have studied stars for a time and divided them on on the on basis of their ages and temperatures. We will wish and discuss one such classification today, and which is discussing about the stars and is the stellar classification of stars. Stars are classified by their spectra and luminosity, and by their spectra of elements that they absorb, and their temperature. There are 7 main type of stars in order of understanding all of them. Decreasing temperature into this line or code O, B, A, F, G, K, and M. We all see the stars twinkling, but in reality they don't twinkle. Have you ever wondered how do stars twinkle? To answer this, let's go back to our school. And let's go back to our school days where we taught refraction of light means a twinkling of stars caused by the passing light through different layers of a temperature's atmosphere. But in the real life, stars don't twinkle, and they only appear as such as because of the interaction between our eyes and the stars themselves, and also Earth's atmosphere. And the formation of stars is not a quick process. It takes around millions of years to form. And a star from accumulation of gas and dust comes from gas and dust which collapses due to gravity in its nebula, a gaseous nebula that creates the star. And our universe has nebulas in which the stars are being formed all the time. Though we haven't seen many observed, much of these stars present in our infinite universe. But those which are observed give us a good example or idea of this composition and properties. And now let us get back to the basis of the topic, stellar classification. It's a scheme of classification stars. They're typed on the basis of their temperatures and as calculated from their spectra. The classification of a temperature is done by the basis of winds while regarding black body radiation, and they universally told us by is this law, basis of winds law regarding and an accepted system of stellar classification is a combination of two schemes, and the Harvard one system, which is based on the star's luminosity, and the NK, also called Yerkes system, is the work. Like the star type, the American astronomers W. Morgan, P. Cannon, and a few others is based on two schemes or two of grades, and for I is a sub for supergiants like II, bright giants, 3 stars, normal giants, and 5 stars, which are subgiants, and V, which means the main sequence stars, and sequence or dwarf stars. Further speculation may be used, such as a grade for a bright white dwarf or a supergiant, a grade 6 and a grade 7 for subdwarfs and white dwarfs respectively. In the Harvard system, the stars are classified as the hottest to coolest using letters such as Q and B, A, F, G, K, M, where O is the hottest, 25,000 kelvins, and blue in color, and M is the coolest. Look, M is the coolest, where it is 3,000 kelvins, lower than us in the sun. And the 3,500 Kelvin star, which is in red in the color, the letters are further subdivided from hot to cool. And an adapted and famous mnemonic for memorizing this sequence of stellar classification. Oh, be a fine girl, guy kiss me. And the hotter stars are sometimes referred to as the early and the cooler as late, with the discovery of brown dwarfs, objects that form like stars but do not shine through the nuclear fusion system of stellar classification, and has been expanded to include spectral types like L, T, and Y. Now let us know about the classification in details, starting with the letter O. Type stars are the hottest and luminous and rarest of main stars. They have a very compacted surrounding, which make their measurements easy to kind of difficult. Most of the massive stars lie within this particular type. Because of their massive and giant size, they have very hot cores and burn through hydrogen fuel very quickly. And so they tend to burn brighter, and the first stars to burn brighter, and are the first stars to leave the main sequence stars. And their spectra have dominant lines of absorption and sometimes emission for second line, and they are sometimes neutral. Neutral spectra, and helium lines and prominent ionized. Further subdivision includes O3, O7, and ON extra spectral. And types O7 is the point which two insidies are equal. And type O3, the point of which a line vanishes. And now comes the letter B. B-type stars are also very luminous and blue in color. Their spectra have neutral helium ions and are very energetic. Short around 40, and they have short lives around 40 million years. And many stars that we can see from our naked eye of from our naked eye are this type. Only B-type stars originated from an OB oscillation that is related to this type, to giant molecular clouds. Now the question is, what is an OB association? And an OB association is a loose grouping of several thousand stars, and a small fraction of which are spectral type O and type B. Type O and B, and is loose a grouping of several thousand stars, a small fraction of which are O and type B. And type B stars also produce B-type spectrum and is also detected in O and B-type shell star. B stars are heterogeneous sets of stars with B spectral types and emission. These emissions are a lot of emissions, like lines. According to the research, it was found that they can have a disk which can create and can orbit or create an emission, and subgiant and giant stars are also included in the orbit system. They have an orbit. This ad will be good. And next comes letter A type. Stars are young, around a few hundred million years. They have a type stars are young, and the young are around a few hundred million years. They have masses ranging from 1.4 to 2.1 times the mass of the Sun, and surface temperatures between 7,112 kelvins to 11,500 kelvins, and they appear bluish white in color and very bright, and we can be seen. It can be seen from our naked eye. This is the A-type stars. They have 1.4 to 2.1 times the mass of the Sun, and a surface area between 7,112 kelvins to 11,500 kelvins. And type stars don't have a convective zone or convective region, I.E, and a region where a layer of star is unstable or conversion, and as a result they wax strong. And stellar winds are not able to bear magnetic dynamo. Research proved that gigantic planets formed around them are harder to detect using a certain method called Doppler spectroscopy, and it's an indirect method for finding exoplanets, i.e. planet outside of the solar system, and brown dwarfs from their radial velocity measurements, and weighing between 1.0 and 1.4 times the mass of the Sun. Their temperature lies between 6,000 kelvins and 7,600 kelvins. This is the F-type stars. They are moderate hot, and they are known for emitting a large amount of light in the form of radiation. For example, UV radiation, which is harming our planet Earth. They are likely to represent the brightest star and hottest main sequence stars that could possibly allow life. And the best example of F-type is F-type is Polaris Northern Pole star, type of F7 star, which is 430 light years away from our planet Earth. And next up we have a G-type stars, also called as yellow dwarfs because of their yellow color, and are yellow in color, and their weight is between 0.8 to 1.25 times the mass of our sun, and they are currently believed to be 100 light years away from their surface, and temperature are between 5,300 Kelvin and 6,000 Kelvin. This is the G-type star. An atmosphere of fluid evolving super and hypergiants are mildly unstable. This type stars, G-type stars, radiate more light towards the infrared end of the spectrum. The most tons of hydrogen. The most famous G-type is G2 type. Star is sun. Each second, the sun fuses approximately 600 million tons of helium or tons of hydrogen to helium in a process known as proton chain. From one helium, converting about 4 million tons of matter to energy. Apart from that, other known stars have under this type is Alpha Centauri A and Theta Ceti and 51 Pegasi. And next type is the K-type stars. Appear orange and are cooler than the sun. They are range of temperatures between 3,500 to 6,000 kelvins. That's the surface temperature of this K-type star. And the G-type, the key interest is to research on this type to find life because stars, because their stability, small mass, greater heat zones, they emit less UV rays, radiation. To focus on the research for exoplanet and extraterrestrial life, the nearest K-type star is also our Epsilon Eridani, which is 10.5 light years away, and HD 1923110 is 29 light years away from our Earth. And Helios 86 is 35 light years away, and 54 Piscon is 36 light years away from us. These are the nearest K-type stars to our planet, and they have life. And the last type we have is the M-type stars, also known as red dwarfs, are the smallest stars and their coolest red color star with such low luminosity that none can be seen from our naked eye. And despite of being called as the smallest, they too include some giant supergiant stars. Big stars and hypergiant stars, a range of their surface temperature from 2,400 to 3,700 kelvins, and red dwarfs have masses from about 0.08 to 0.6 times that of the sun's mass. And the lighter stars that are extended spectral types have been also included. A number of new spectral types been taken into use from newly discovered types of stars. This is a basic video, so will not include these extending spectral types. But if you want me to know about them, let us know in the comment section and we will make a new video only on these.